we have 4 rules, or we call them properties, for logs that we'll look at for today. But you do need your calculator to get us started kind of as we warm up for this. So using your calculators, could you figure out for me the answer to that question? Log 7. Okay, using a calculator. Go ahead, type it in and then write down what you get. 3 decimals would be great. Okay, Mary Lou, what'd you get? Okay, 0.845. What is the meaning of that? What does that mean? Because a logarithm has to have a meaning. Calculator just spits out that number. Okay, and what does that mean? Well, we talked on Friday about logs like this that don't have the little teeny base number. And when we don't write it, what's implied? Okay, so how does the 10 fit into that problem? Hayden. Is it? Check it on the calculator. 10 to the 0.845. What do you get? 6.99 what? What else after the 8? 2? Okay, so it stays an 8. How would we get more accurate? How could we get closer to 7? Write more decimals when? Yeah, after the 845, you would put more decimals, which would get you closer to 7 when you checked it. All right, so exactly, that's how you check your work. That's where the 10 comes into play. All right, you also have this button on your calculator. It's called natural log. It's not called line. Okay, natural log. And so type in natural log of 7. You're not going to get the same answer. Okay, go ahead, type that in. Okay, Alex, what'd you get? What comes after the 5? Okay. All right, what is understood and implied but not written in the question? What's the little teeny number that we typically don't write because it's implied? E. Okay, so we imply that there's this little teeny little e right there. Well, what does e have to do with the problem then? Okay, e to the 1.946. All right, check that. We work out like spot on, 7? 7.0006, which would be 01. Oh, there's another 0 besides that. Oh, what I had was fine. What comes after the 1? That's what I had the first time. And then he said it wasn't right. There we go. Okay. Okay. So that is with the implied 10. And that is with the implied E. All right. Well, what does it mean then if I ask you to do the log with an implied base of 7, but we use 3? How do you do that? That's where we need our very first property or our very first rule. So when it's not 10 and it's not E, then what do you do? All right, so here is your first rule. We're going to put it in a box after we write it. All right, so if you have a log and it's not base 10 and it's not base E, then you can do the following. You can switch it to a natural log of the number A and then divide it by the natural log of the number B. That is your very first property. It's called the base change property. It's when you change from the base that you're given to the base of E instead, and you use that property. So that would allow us to be able to figure out what the log base 3 of 7 is. So that's our first official example for today. Use the calculator to evaluate the log base 3 of 7. And so you'll type into your calculator, actually you'll write on paper first, the ln of 7 divided by the ln of 3. That's the base change property. You change it from a base of 3 into a base of E. And then you'll type that into your calculator, Okay. Trev, what'd you get? Okay, go ahead. Oh, thanks, Alina. 1 point what? What was the very last thing? 1? All right, how would we check our work on that? Okay, we check it with the original 3 to the 1.771, and hopefully we get something close to 7. 6.998 again. Okay. So you'll get questions like, you might just get your answer, but well, what does that have to do with it? Like, how does that connect back to the original base of 3? Because it's easy to just type something into a calculator and get an answer, but you need to know how it connects. How are all those numbers connected? How's the original 7 and the original 3 and then the answer 1.771, how are they all connected to each other? Okay. All right, you can also use that same base change property to do a question like this. The log base 2 of the square root of 5. So you can turn that into the natural log of the square root of 5 divided by the natural log of 2. Okay, Trevor, you got that one? Okay. I feel like it's taking too long. Is your calculator not working or what? Okay. I got something similar to that. I rounded a little farther, but that's fine. Yeah, 1.161. Great. All right. So, Caden, how does that connect back to the original problem? To the 1.161 should be, all right, check what it is. That's it, just 2.2? Okay. What should that be equal to? It should be equal to the square root of 5, so check the square root of 5 also. Got that, Caden? Checking square root of 5. Yeah? Okay, good. So that checks out as well. All right, any questions on that property? Okay, our second property, actually properties 2 and 3 go together. There is the addition and subtraction property. Properties, plural. Okay, here's how the addition and subtraction properties go. If you have the log with whatever base of capital A plus the log of another base, the same base of capital B, then you can group them together. But log always turns stuff into something else. You know how a log turns a radical into a fraction? A log turns a fraction into a negative? A log turns addition into multiplication. And so you get AB multiplied together within parentheses. The parentheses will be important. And in a similar way, the log can transform subtraction. Oops, I don't want that. Okay, the log base B of capital A minus the log base B of capital B. So what the logs do is the log transforms subtraction into, what do you think? Division, exactly. And so that would be A divided by B. And it can furthermore take a whole long thing and combine it all together. So it can take the log base B of A plus the log base B of B minus the log base B of C. So I mean, it can take a whole string and combine all of that together as well into parentheses, where you end up with A times B divided by C together. And that would work out that way. That could extend for any length that you needed to. The addition parts become multiplication, which become part of the numerator, and the subtraction parts become division, or part of the denominator. All right, so let's put a box around that. Those are the properties for addition and subtraction. So let's work with some of those. So sometimes you might have ones that start out like this. The log base 2 plus the log base 3. Excuse me, the log of 2 plus the log of 3. And we understand that the implied base is what here? 10. All right, and the logarithm transforms that that addition into what? Multiplication. So the answer is the log base of. Wait, what wrong answer do you think might be one of the multiple choice options here? Log base 5. For sure. Okay. You could also take the log base 3 plus the log base 4 minus the log base 6. Okay, so altogether that would become in parentheses 3 times 4 over 6, which would simplify because it's in parentheses. So what would the final answer be? The log base of 2. 3 times 4 is 12, divided by, reduced by 6 is 2. It works with variables. So you could have the ln of x minus the ln of y plus the ln of w minus the ln of z. It would squared. Okay, I mean you could have any number of things here. The addition parts will be part of the numerator. The subtraction parts would be part of the denominator. So ln would be the group together, and it would be transformed into what in the numerator? What do you guys think? Not ln of x and ln of w. It's ln of xw. There's not a separate, it's one natural log. The parentheses are around the whole thing. That's why parentheses are important. Okay, whoops, I wrote. Okay, x and w. The denominator would be the subtraction parts, and so I would have y and z squared all together. So notice how it took 4 separate natural logs and combined them into one single natural log. But you can go the opposite way. You can separate them and work backwards. So you could take the log of a squared b over c rad d, and you could be asked to separate that. Okay, does anybody want to try it? How would you separate that? Yeah, think about it for a minute. Anne, do you want to give it a try? You can do it. Plus, very good. Okay, and what else? Okay, switch to minus log base c, and another minus log base rad d. Okay, very good. So you can use this property to combine things or to separate them, depending on the question and what direction you want to go. Okay, any questions about that property? Okay, last property. The last one is called the power property. Okay, the power property says this. If your log has a base and a number, and it also has a power. Let's just call it P to keep it generic. Okay, it also has a power. The property says that you're allowed to move that power to the front. And so it would be transformed into P in front of log base B of A. And then there's a little like sub-corollary under there, which says in the special case, if you would have log base B of B and have your power P like that, in the special case where there's B is doubled up, B is both the value of the base and B is the value of the number, if you pull the power to the front in that special case, you'll still have P in front. But what will also happen is that the log base B will cancel out the regular B. That's only in the case where the two of those match. And what it's the only thing you're left with then? P is all that you're left with, is the power. That's the power property. So the power property is always move all the powers to the front. And then if you can do more, like simplifying, then by all means do it. But if you can't, then stop where you're at. And so that is the final property, and we're just going to practice with that and then kind of mix all the properties together and see how powerful they all are. Okay, so if we had, for example, the natural log of x to the fifth, that's an easy move. The easy move on that is that the 5 pulls to the front, and we end up with 5 ln x, and there's nothing else to do there. You can't go any further because the implied base is e, and the other number is x, and they don't cancel each other out. You could have the log base of 8, and you might initially think, well, there's no power there. But if you know your math facts, you know that 8 is a power number. And what is 8 written as if you use powers? It's not 4 squared, because that's 16. What's 8? 2 to the third. You got to know your math facts. You got to know your powers. You got to say, oh, 8, I know that number. Or, oh, 27, I know that one. 81, I know that one. 36, 25, 49, 16, 256, 121. All right? So you know your math facts, and then you can pull the 3 to the front. And you end up with 3 in the front of log of 2. And the implied base is 10, so there's nothing else you can do there. Okay. You could do it with a log base 4 of 64. And hopefully, you think, oh, I know that. Okay, 64 is 4 cubed. 64 is also 2 to the 6th. So you could do either of those. Let's do 4 cubed. We'll move the power to the front. That would give me 3 in the front, log base 4 of 4. And here's your first opportunity where the base is 4 and the value of the number is 4. And so they cancel each other out, and you're left with 3. Okay, you can do the ln of the square root of 11. At first glance, just like the 8, you looked at the 8 and thought, I don't see a power. And maybe you look at the square root of 11 and you think, I don't see a power. But we know that logs transform radicals into what? Fractions. This is 11 to the half. And half can get pulled to the front. And we now have half ln 11, where the implied base is e, and we can't cancel anything else out. So what I want to do now is mix some of these properties together with numbers and variables and see how we can do. All right, separate. So when you're asked to separate the log parentheses 3x squared y. When you're asked to separate that, that's using the property of addition. And so you'd separate that into the log of 3 plus the log of x squared plus the log of y. But you can also apply, after you've separated, you can apply the power property by noticing there's still a square sitting there, and you can move the square to the front. And so this answer would be the log of 3 plus 2 log of x plus the log of y. So that's a question where you would separate something, and everything would all be separated into 3 separate logs. The reverse of that would be combine. So let's try it combine. Combine is where you start with all separate logs and you put them all back together. So let's combine an ln of x plus an ln of x minus 2 minus a 3 ln x. Now we're asked to combine all of that. Before you can combine, you have to get rid of any coefficients. Here's a coefficient right there. So you got to put it back. If that 3 is sitting in front, where did it come from? It came from being on the x, so now put it back. Okay, put it back in that spot. So ln x plus ln x minus 2 minus ln x cubed. Then combine them using the adding and subtracting properties. So that would be 1 ln with parentheses. It's not 3 separate ln's. It's 1 ln, and then everything goes into parentheses. So the numerator would have x and x minus 2. The denominator would have x cubed. And you can reduce the x with the x cubed. And that would leave you with ln parentheses x minus 2 in the numerator and x squared in the denominator. That's just basic reducing x with x cubed makes x squared. Okay, one final one, and then we're done for today. It's a separate again. All right, separate. So let's do log base 5, and we'll start with parentheses. And in the parentheses, we will have the square root of 4x minus 1, and then we'll have 8 parentheses x minus 2. All right, first we separate. Log base 5 of rad 4x minus 1 minus log base 5 of 8 minus log base 5 of x minus 2. So that's the first part, is the separation. The second part is the powers. And again, you might look at that and say, I don't see powers. But you got to train yourself to see a power in the 8, and you have to train yourself to see a power in the radical. Because the log turns that radical into 4x minus 1 to the half. And it turns the 8 into 2 cubed. And it doesn't really do anything to the x minus 2 because there's no powers there. And then we're going to move both of those powers to the front of their separate logs. So your final answer will have a 1/2 in front of the log base 5 of 4x minus 1. It will have a 3 in front of the log base 5 of 2, and it'll have nothing in front of the log base 5 of x minus 2. So that's called the separate problem. So there's a difference between combining and separating. When you combine, you should have a separate log. When you separate, you should have a separate log for every piece. When you combine, you should have a single log around parentheses of the whole group.